Okay, finishing up lesson 34 today, summation notation and decomposing functions. For summation notation, we will be using the uppercase Greek letter sigma, which is simply going to mean sum. It means we're going to have terms that we need to add together. When you see this notation, it will look something like this. You will have the sigma, then you will have some kind of a formula, and that is the formula for the terms. What are all of the different terms that you need to add together? It will tell you one variable, in this case y. That's the variable that you will be substituting in for in the formula. The numbers mean, for this one, you start with 1. So you substitute in y equals 1, then you substitute in y equals 2, then you substitute in y equals 3, then you substitute y equals 4. You keep going until you get to the top number. So this is the last one that you substitute in. It does not have to start with 1. You will have some that have a summation as, and maybe they use n instead of y. They can use any variable they want to. Maybe they start with -2 and go up to 1. That means you substitute in n equals -2, n equals -1, n equals 0, n equals 1, and then you stop. Or you could start at 5 and go up to 12. You could substitute in 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12. So those index numbers just tell you what you start and stop with and which variable you plug in for. So let's actually evaluate this one. So this says I need to plug in 1 for y, so I get 1 squared. Then I plug in 2 for y, so then I get 2 squared. Then I plug in 3 for y, so I have 3 squared. 4 for y, I get 4 squared, so that I have 1 plus 4 plus 9 plus 16. And 9 and 1 are 10, 4 and 16 is 20, 10 and 20 gives me 30. Let's change it just a little bit. Let's suppose that my formula was not just y squared. Let's suppose that I did the sum as y goes from 1 to 4 of a y squared. Nothing about what a is. I can only be substituting for one variable with this notation. So a is going to stay a. That means I will have a times 1 squared plus a times 2 squared plus a times 3 squared plus a times 4 squared. My a is not squared because I don't have parentheses around ay, only the y is squared. So that gives me 1a plus 4a plus 9a plus 16a. So in this case, I'd have 30a, and that's okay to have. Questions on that example? Okay, since this is kind of new and different, let's do a couple more examples before we move on. So this time, k is 1. This time, the k shows up in 2 places in the formula. So as I go through to figure out my terms, I need to put 1 and then 2 and so on in for each of the k's. So that means when k is 1, I'm going to have 3 to the first over 1 plus 2. When k is 2, I'm going to have 3 squared over 2 plus 2. When k is 3, I have 3 cubed over 3 plus 2. I only go from k equals 1 to k equals 3, so I've got all of my terms up there. Now it's just a fraction problem to simplify. It's no longer an algebra 3 problem. So we have 3 over 3, or 1, plus 9 over 4, plus 27 over 5. And since 3 over 3 is just 1, looks like I can use 20 for my common denominator. So 1 is 20 over 20. And let's see, then what do I need? Plus 45. And then 27 times 4, 108. 4 times 7 is 28. Carry the 2. 4 times 2 plus 2, so we get 108. And then if we add all of those up, 5 and 8 is 13. 1 and 2 is 3, and 4 is 7. 173 over 20, is that what you guys got on it? That look right? Okay, questions with that one? Okay, last one of these that I'm going to do is a special case. So this time, like I mentioned, we don't have to start at 1. We're going to start at 5. So if I is 5 and I plug in for all of the i's, what is 6? Does I have anything to do with what 6 is? So what is 6? So when I is 5, the first term is 6. When I is 6, what is 6? Keep going, I haven't gotten to 7 yet. When I is 7, what is 6? So in this case, the index variable had nothing to do with terms. It is only letting me know how many of them I have. And so if I have 3 6s, I have 18. So feel more or less okay with that. I know it's the first time you've seen that kind of notation. And let's move on to the other topic for today's lesson, decomposing functions. So first we're going to review just a little bit with compositions, so then we can kind of see what that's going to look like if we go backwards and undo a composition. F of g of x means f of g of x, where g of x is on the inside, and f is on the outside. G of f of x, on the other hand, looks like this. Now, f of x is on the inside, and g is the one that's on the outside. So if we look at it when it's written like this, f of g with a little o in between, that means that this last one is the inside function, and the first one is the outside function. That's going to help us when we are looking at some of the final answers for compositions. We're going to say, oh, what looks like it's on the inside, what looks like it's on the outside. That's why I wanted to review it with this vocabulary for talking about it. So let's take one where we know what the functions are, and we need to do the compositions. So this says I need to take f of g of x. But g of x is x squared plus 3. So if I am plugging x squared plus 3 into the f rule, what do I have on that one, Ava? Perfect. The square root of x squared plus 3. Do you see how that one looks like x squared plus 3 is on the inside? And the square root symbol looks like that's on the outside. Let's go the other way. If we now did g of f of x was the square root of x. So now we're taking the square root of x, and that is what we're putting in for the function g. What does that end up giving, Maya? So root of x squared plus 3, and let's see. If we're taking the square root, that means x had to be non-negative. So when we square it, we do get the x, which was non-negative. So we could also just say that is x plus 3. Now in this case, does it kind of look like that square? This one's a little harder to see in terms of the inner or outer, but this was kind of what we did first, and then we squared and added 3 to it. Let's start seeing if we can go backwards. Some of these will have more than one way that we can do them. I will tell you that one way that I will not accept is I will not accept if you ever say f of x or g of x is just x. Because it's always true, you could say f of x, or you could say f of x is x, g of x is x squared plus 6 all squared. That's no thinking, that's boring, you haven't really done anything. So I want a better way of coming up with some different things than what you've got here. So we're going to look at this. This means g needs to be the inside one, and f needs to be the outside one. So I want you to look at this, x squared plus 6 all squared, and come up with an idea of what might be the smaller piece somewhere on the inside that we might do first. What looks to you as you look at that like it might be an inside function. There is more than one way to do this. Jack, you have an idea? So one way to do it would be to say x squared plus 6 is on the inside. So I'm going to put a circle around that. I've already done that part. Now f has to be the outside part, so Kinsley, what is left to do to that? I've already done the circle. What do I still need to do? I still need to square it. So if my argument right here is x, my argument here needs to be x, and then I square it. Okay, let's see if we can come up with another way. As you look at x squared plus 6 all squared, does anybody see another piece that looks like it might be something that you could do first? A different way of looking at the first or inner step, something that's smaller than x squared plus 6 in this case. Okay, what are you thinking? Let's put that down, please. That's not part of what we're doing now. What's something smaller than x squared plus 6 on the inside? Smaller than x squared plus 6, but not just x. Abby. Good idea, but we don't want to change. I want something that you actually see up there, and I don't see a root 6. What are you thinking, Elizabeth? What about just x squared? Let's see if we could make that work. So the inside part, we could say, is just x squared. So now we've done that part. Now f has to do everything else except for what I've circled. So Ariel, what is still left that we need to do to the circle? Okay, so we need to take the circle plus 6 and then square it. But if I put x in here, that means x is my argument, not circle. So I'm going to say x, and then I need to add 6, and then I need to square that whole thing. Either one of those would give f of g of x is x squared plus 6 all squared. Let's try another one. So same directions. Now we want to get two functions so that this happens. For this one, f is going to be the inner one, and g is going to be the outer one. So as you look at 1 over x cubed plus 4, what looks like it might be one of the smaller pieces kind of on the inside. Grace. Okay, hang on just a second. So we could do fx is x cubed plus 4. And then we still need to do something to that circle to have the final composition. So what do we still need to do to that, Grace? We need 1 over that. So if the argument is x, 1 over whatever that argument is. Okay, can we come up with another way of doing it? Instead of taking the whole denominator, is there a smaller piece? Avery. We could just do x cubed. And then g of x would be everything that's still left to do. What do I still need to do to the circle for this one? Olivia? I still need to do 1 over the circle plus 4, but my argument is x, so instead of circle, I write x again. So if they just give you the final result, there may be more than one way you could do it. You only have to do one, but we may have more than one correct answer for that. Sometimes, however, they will give you the final composition, root x squared plus 4, and they will tell you what either f or g has to be. Then there's only going to be one correct possibility. So for this one, g is inner or outer? Inner. And so this says the inner one is x squared. What do we still need to do to that part that I have circled to get the final composition? Sophie, you have an idea for me? Say that a little louder. Okay, if I take the square root of the circle, will I have the whole thing, or is there another little bit still to do? I still need the plus 4. So I still need to do square root of the circle plus 4, but I can't really put circle in for my argument. I have to use an x, so it will look like that. Okay, this time around, we get our composition is the cubed root of 2 minus x. This time they tell us f, which is inner or outer. That's the outer one. That's what we're going to do last. So the last thing we're going to do is to take the cubed root. What do we need to do before we take the cubed root? So what does the inner function g have to be? What have I not circled yet on this particular one? Catalina, what's not circled yet? The 2 minus x. So g of x would have to be 2 minus x. So we do this first, then the cubed root, and we have that. So does anybody have questions with that? I need you to hang on just a moment here.